Hey, what's going on, guys? Let's do this problem right here. The first question is asking if the intensity level at distance d of the one tombstone is 70 decibel, what is the intensity level of 100 identical, actually trombone, right? 100 identical trombones, all at distance d, right? So let's see how we can calculate this one. So first one, they have given one trombone is 70 decibel. So it's 70 decibel. So if I want to convert into watts per meter square, because we have to convert into watts per meter square to do the calculation. Here we know that 0 decibel is 0 decibel is equal to 1 times 10 to the power of minus 12 watts per meter square. 0 decibel. So if I want to convert into 70 decibel, I just add 7 power to this power, right? So if I add 7 more power, this is going to become 1 times 10 to the power of minus 5 watts per meter square, and this is equal to 70 decibel. So that is equal to I1, right? One trombone. What happened? So let's write. What happened if you have 100 trombones? We just simply multiply this value by 100. And if I multiply this one by 100, this is going to be 100 times 1 time 10 to the power of minus 5 watts per meter square, and that's going to give me 1 times 10 to the power of minus 3 watts per meter square, and this is equals, if you see the power is increased by 2, so it means each power increase, the decibel increased by 10. Here is increased by 2, so it's going to be increased by 20. Here we are going to have 90 decibel, and that is the answer for the first question. Therefore I100 is equal to 90 decibels. And let's do the second question. The second question is asking 25 meter string vibrating in its sixth harmonic excites a 0.96 meter pipe that is open at both ends. So we have a pipe that's open at both ends, and so whenever they are saying excites another one, it means the frequency are equal. So whatever the harmonic it has and whatever the harmonic the pipe has is going to be equal in this situation whenever they are excited, right? So that is one thing to consider. And let's go further and read this question. So 0.96 meter pipe. So the pipe length is given 0.96 meter. Then that is open at both ends and into second overtone and second harmonic above the fundamental. So second harmonic above the fundamental means third harmonic, and second overtone also means third harmonic. So it's same words. The speed of the sound is 345 meter per second, and the common resonant frequency of the string pipe is close to what is there. So they are asking for the frequency. They have given the velocity of the sound, that is 345 meter per second. So we know that the equation for velocity is v is equal to f lambda. We can calculate the frequency using this one. F is equal to v over lambda. So here we know the velocity, but we don't know the lambda. Let's figure it out. So they are saying this is third harmonic. So in an open pipe, the first harmonic is going to be something like this, because in an open pipe we are going to have anti-note in both ends. So this is our first harmonic. So let's see for the second harmonic. Second harmonic is anti-note at both ends. So this is our second harmonic. The third harmonic, same thing. So third harmonic means anti-note again at both ends. So this is our third harmonic. And if you look at the wavelength, and we see this distance is one wavelength. If you see the pattern, one wavelength right here. And we have one like lambda by 4 each side. That is, if I add them together, that's lambda by 2. So it's 1.5 wavelength. We can write that one as 3 by 2 lambda. 3 by 2 means 1.5, right? 3 by 2 lambda. And then from this one I can find the lambda. So 3 by 2 lambda is equal to 0.96. Therefore lambda is equal to 0.96 multiplied by 2 divided by 3, that's equal to 0.64. 0.64. Now we have the wavelength, and let's calculate the frequency. So this is going to be 345 divided by 0.64, and if you calculate this value, this gives us 539.0 something hertz, and we can actually approximately say this is 540 hertz, and that is the answer for this question. Second question. Let's do the third question. The third question is asking the density of the aluminium is 2.8 times 10 to the power of 3 kilogram per meter cube. The speed of longitudinal waves in the aluminum rod is measured to be 5 times 10 to the power of 3 meter per second. What is the value of Young modulus for this aluminium? So they are asking for the Young modulus. So let's find out the equation for the Young modulus and velocity related equation. So we have the equation that's V is equal to square root of V over rho. So V is the Young modulus and rho is density. So if this is in square root, let's get rid of the square. So let's square both sides. So this is going to be V square over B. That's going to be equal to V over rho. Our question is to find the B. B is equal to V square times rho. V is provided, that is 5 times 10 to the power of 3 meter per second, and density also provided, that is 2.8 times 10 to the power of 3 kilogram per meter cube, and therefore this V square is going to be 25 times 10 to the power of 6, and here if I multiply this one by rho, that is 2.8 times 10 to the power of 3, and 25 times 2.8 gives us 70. So 70 times 10 to the power of 9, and if I want to write in proper scientific notation, this is going to be 7.0 times 10 to the power of 10 Newton per meter square, and that is the Young modulus for these values. I hope you guys like this video. See you next time.